To introduce myself again, I am Joshua Arvin Lat, and I am the Chief Technology Officer of three Australian startups, CBO, Insights, and Jepto. So my topic for today would be designing and building serverless applications, and I'm going to focus on machine learning-powered applications. So for today, I'm going to make sure that I get to bridge reality and expectations, because this is usually the next step after you have done your Hello World examples. I'm also going to demonstrate some things about what's really happening in production. And I'm also going to share a bit of concepts so that for those who have heard about these things the first time around, you're still able to catch up on some of the things I'm going to describe further in my talk. All right, so let's begin. So this is going to be a quick talk, but I'm going to focus on serverless, the concept, how it's really going to be done in production, and of course, machine learning. I'm going to describe first the process, what are the common mistakes of beginners, and then finally, how do you combine both? So if you look at the screen, we'll start with serverless concepts, and then machine learning concepts, and then we'll head straight to deploying machine learning models, and then finally, how do you manage machine learning workflows? So majority of this talk is going to lean towards serverless architectures. So if this is the first time you're going to hear about serverless, then I'm also going to discuss the details on how these things work in real life. So in my current company, we started trying out serverless architectures probably 3 or 4 years ago. We started with really small apps, and once we became more confident, we realized it's about time we tried to go things further. So when you're talking about serverless, usually the goal there is to focus more on business logic. When you are part of a team and you're working, you get to realize that a lot of things you learn online won't necessarily really be used in real life. And I'll also share the pros and cons when using serverless, because while it solves a lot of problems like cost, scaling, knowing the assumptions, the challenge usually when using serverless architectures would include management of the distributed resources, because you have to deal with a lot of resources. Because you're doing serverless, you're going to deal with small parts. So how do you manage, let's say, the rollbacks? How do you manage the versioning of serverless applications? So in order for us to understand what's really important when dealing with applications, production applications, the usual thing that comes into mind would be time and money. So let's say that your CEO wanted to build a team, and the CEO wants first a product that they can launch into production as early as possible. Given that time is critical, you have to know where the R's are going. Let's say that you have 5 developers in your team, and you want to build an e-commerce application using the serverless architecture. And if you try to do it with a different mindset, you'll come out with with a very different allocation of time. So before, for the past 5 to 10 years, the challenge there would be, I'm going to build a web application, I'm going to build an ETL system or something. And majority of the time, given that a lot of things have to be installed in your local machine, and then you have to prepare your staging environments, the challenge there would be, I spend 80% of my time, or the time of the developers, trying to build something that other people have already built. But once your startup needs to compete with other startups, the challenge there would be, well, technically, the only thing that makes your startup different from the other startup would be the idea. Another would be, how custom would your solution be, and how better would be your custom solution be compared to the solution of your competitors. So if you had 100 hours, would you rather spend 90 hours preparing something that your competitor already has? Or would you spend those 90 hours focusing on business logic? Because the more you try to do things and try to maintain servers, try to install patches, try to do system administration, you spend less time on your custom logic. Let's say that your machine learning model can do this, but you were only able to spend 10% of your budget doing that, and doing a lot of R&D, spending a lot of resources, doing things which may not necessarily be going to directly impact your revenue. The thing about startups, for a really long time, we have to make sure that we get to test a lot of our features and have to have our customers use the features directly and immediately. If I was given a project, and let's say I have this idea, let's say a facial recognition system, I do not want to spend 1 to 2 years trying to launch that system. I want to know if that's going to work in the market. And the goal of serverless here is for people to focus less on the system administration part, focus less on scaling, and focus more on the actual custom logic, which will make your business work or not. So this is one example. So in my previous example where I mentioned something about image analysis, facial recognition, there's a tool in AWS called Amazon Rekognition. Sometimes when we are people who really want to try all those machine learning stuff that we learned online at work, that tendency would be, oh, give me all of this resources, all of this time, give me this team, we're going to train our own model. But you try to forget the most important part in data science. The most important part in data science and machine learning would be listening to the customers. Even if you have all the solutions, if you have the most high-tech set of tools out there, if you don't get to solve the problems of the customer, your solution won't make any sense. You're trying to solve something which may not directly be needed by your company. So in this example, suppose I were just to use Amazon API Gateway, AWS Lambda, and Boto3 in Python, and use Rekognition in S3, I would be able to do this in 4 to 8 hours, depending on how I am familiar with the SDKs and APIs. Do I need to train my model for that? No. I use my time wisely, and I am smart for thinking of other solutions before I try to reinvent the wheel. How can we guarantee that the model that we train is better than someone else's? So I'm just going to give out some examples so that if you want to get started with serving models in production, you have to also take into account the constraints like time, the budget, and do you even know if you will have customers for that idea? Some ideas may sound nice when you're trying to talk about it, but when you try things out in production and you want to have a startup that deals with that idea, the challenge there is sometimes the customers do not want it, or maybe there's already a competitor that has gained all the customers that you want. Another example would be language translation. So of course, you can just replace Amazon Translate with another API out there. But this is one example of something similar to the previous slide. So in this slide, let's say I wanted to translate English what to Japanese. So let's say I'm a researcher who has been dealing with all these things for about 10 to 20 years. Then I can safely say that I can build that model. But if I am a student who just graduated and I wanted to prove that I am something reliable in the machine learning community, it would be bad for your company to try things out on your own without actually trying to test your idea out in the market first. And it's better to assume that things will go in phases when you launch things, because trying to do these things is not easy. You have to have subject matter expertise and years of experience doing that. Trying to read your blog posts, trying to read books, that's not enough to call yourself an expert. So the translation of what would be, so I'm not sure about the pronunciation, but it would probably be nani, so something like that, and that's not straightforward, especially when you have to do things by yourself. If you want to customize that, think about the services first that already exist out there in the market. So of course, you can try to check out what GCP has, what Azure has. So in this example, I just use Amazon Translate because it's probably just a one-liner code. All right, so let's now talk about machine learning concepts. So when you're dealing with machine learning concepts, the usual mistakes that beginners make would be trying to go deep dive into certain algorithms right away. So the moment you hear about buzzwords, the moment you hear about those cool stuff in the internet, the challenge there is that you get to trust the marketing side too much. But when you try to study it and when you try to apply it in real life, you will realize that it's very specific to certain problems. When you're dealing with machine learning applications, you have to know what the customers need first. You will never use a single tool. So in this case, if all you have is a hammer, everything becomes a nail. If all you know would be this one algorithm, or just two algorithms, the problem there is that you are stuck with those two. And if that's not the best solution for your problem, then you may end up giving instructions to your people and telling them that blah, 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 this is going to work. But in reality, a different algorithm with a different set of rules and constraints would work better. So in your case, the better way to approach machine learning and data science would be to know first what's available out there. What algorithms are available, what are the constraints and assumptions for each algorithm. And you have to know that when you're dealing with machine learning projects, you're not going to deal with just one model at any point in time. You have to deal with multiple, different iterations, different variations. And you have to test which one is better than what, and which assumptions should you think about before starting about using an algorithm. And then, the common mistakes that beginners usually make would be, they do not understand the process. They just want to use the tools and they just want to call themselves data scientists. And the problem there is that you get to miss out the bigger picture. So let's try to talk about the process. So it starts first with data collection, then you prepare your data and clean your data, and then you visualize your data so you have more opportunities to understand the data better and do some adjustments. And then finally, feature engineering, model training and parameter tuning, model evaluation, and model deployment. So a lot of things that you'll read online would be model training and hyperparameter tuning, feature engineering, etc., and data visualization. But usually, the one thing that people usually forget about when they're starting out with this kind of process is that they have no idea that the model evaluation part is one of the more important things in data science and machine learning. Understanding confusion matrix, learning about the different ways to assess your model, and knowing which model is better for what scenario, what are the legal constraints of using a model, etc. You have to understand that the last two parts are the things that you should be focusing about when you want to use this at work. And then when you're doing model deployment, it doesn't mean that you can do all the other things right away and you have models. It's that you can deploy it right away. You have to think about a different part of the data science process, which is machine learning engineering, which is a combination of software engineering and machine learning. Being able to use the things that you've learned in software engineering, like scaling, proper engineering techniques, deployments, that alone is a separate topic. And usually when dealing with machine learning topics, that's the part where the world still has to catch up on. So this is one example of, this is a simplified example of using scikit-learn in Python. Like I mentioned in my previous slide, the one that's usually forgotten would be the evaluate results part. And even if you saw that the process looks linear in the previous slide, it's not really linear. I just simplified it for the sake of it being consumed right away. But in reality, the world is not as simple as that. And in this case, the moment that you get the model, you get to use fit and predict and evaluate the results, it doesn't stop there. It starts to get trickier once you have to host it into production. So the challenge there is the first thing that you have to think about is when you're dealing with machine learning applications, you have to think about the resources it needs to process your data. So doing training, testing, and even prediction, it requires a certain amount of resources, and you will have to pay more, or your company has to pay more for the resources that you use. The challenge there that we want to solve is that, let's say you have a warehouse, a really big warehouse. The challenge there when you're renting a warehouse is you get to reserve the entire thing, and then once you reserve it, what's the guarantee of that being used right away, 90% of the entire warehouse? It's like reserving the entire thing, and you have no guarantee that it's going to be using 90 to 100%, meaning you over-provision for a certain amount of time. When you're using serverless application techniques, the thing that you have to think about would be the business logic. And as long as you know the constraints and how you work with these tools will allow you to just put in your model in a certain technology, service, and then you just assume that it works. But it doesn't work like that in production, because even the things that you read online, that's not enough, because you have to do experimentation yourself. So now, just to give some examples on how to make this work in production, one of the easier ways to get to deploy something in production would be using SageMaker. So of course, there may be other tools out there which can replace SageMaker, but for the example of this demo, I'm going to use scikit-learn and SageMaker for the first 1/3 of my presentation. So with SageMaker, the code is very similar, more or less, to how you code it locally. Or let's say you have an instance and you run a Jupyter notebook and you want to use scikit-learn. So train, test, evaluation, and then where do you get to predict these things? So with SageMaker, all you have to worry about is a single line of code. And then out of nowhere, SageMaker automatically launches an EC2 instance for you and deploys your model inside a container inside that instance. And when you have to auto-scale, you don't have to think about it because SageMaker does it for you. So let's say you want to do a proof of concept and you want to have a simple web endpoint trying to predict things for you. SageMaker is one of the easier ways to solve your problem. So if you know about scikit-learn and you have no idea about SageMaker, just think about SageMaker as an API endpoint or a service that just does the things for you. Examples would be uploading your model inside S3, for example. Launching an EC2 instance where your model will be served. And then finally, doing auto-scaling, and it can also help you with your deployments to allow you to be able to test your models in a more systematic way. All right, so part 3. So I think part 3. So deploying machine learning models. So this one, we're going to use AWS Lambda as an example. So AWS Lambda, I'm going to talk about the constraints and techniques on how to deal with these constraints. I'm also going to talk about serialization and deserialization. And then finally, the architecture. So AWS Lambda is basically the service of AWS that deals with the function as a service concepts. When you run that function, you only pay for the seconds or milliseconds, I can't remember, for when your application is running. So when, let's say, you're using an EC2 instance, your warehouse, and you run it for 24 hours, and nobody is using that, or very few people are using that endpoint, the problem there is you're going to pay for the 24 hours. Of course, you can do auto-scaling with EC2, but that will require you some engineering work or some DevOps work to get that to scale. But when you're doing work on top of AWS Lambda, the advantage of using AWS Lambda is you don't have to take care of the auto-scaling and the other parts when dealing with deployments and resources. It automatically scales for you as long as you know what you're doing, and you pay per the second. And it makes things more testable that way, because sometimes you get to do things in an EC2 instance and the things blow up there, and it's hard to separate the other microservices properly from your giant architecture. So when talking about serverless, you're not just talking about AWS Lambda. And when you're using AWS Lambda, of course, you're doing serverless. But when you're doing serverless, it doesn't necessarily mean that you're using AWS Lambda. So what's the difference? The difference when using serverless is that as long as you're not managing any servers, let's say EC2 instances, doing patching, it's serverless. So when you use AWS S3 and you have an Angular app or a Vue.js app on top of S3 and it's working, it's serverless, even if you don't use Amazon Lambda. And when you're dealing with serverless architectures, you have to think about how these components communicate. So in talking about how these things communicate, of course, do you think that a single Lambda function would host all your application code? Probably not, especially for more complex applications. You have to deal with multiple. And once your project gets bigger, you have to deal with more Lambda functions, you have to deal with more resources, and you may have to use, let's say, AppSync or API Gateway to manage your web endpoints and how you deal with the logic and how do you combine the Lambda functions along with it. So when you're doing serverless architectures, you have to think about APIs. Your AWS Lambda serves as a glue, and your AWS Lambda is used to connect the different services. So now let's try solving the problem directly. Let's say this is my problem. So if you look at the screen, this one. So if you look at the screen, let's say you have three libraries, Python libraries that you want to host inside AWS Lambda. When you want to host things inside AWS Lambda, it's not as straightforward. You have to know what you're doing. When you're going to build simple applications in AWS Lambda, it's easy. You can just use the UI, code some Python code there, and it will work right away. Once you have to install relatively more complex libraries that exceeds the constraints of AWS Lambda, it becomes harder. So our goal for the next 3 minutes would be thinking about ways on how to get those prediction endpoints to work. The first one would be using the same example earlier, which is scikit-learn. And we want to use scikit-learn inside Lambda and have it called or triggered using API Gateway as the event source. On example 2, you have TensorFlow and Lambda triggered by API Gateway. And then finally, Facebook Prophet will be triggered by API Gateway as well with a prediction endpoint. So how do you solve this? So before thinking about solving the problem, you have to know about the constraints of using AWS Lambda. First, time. When you're using AWS Lambda, it has a time limit. Every year, it may change, but you have to assume that it will be running for a short period of time. The goal for any engineering team would be, how do you reduce the time to, let's say, 1 second or 2 seconds? Because you have to pay more for each second. So let's say that your prediction script is running for 20 seconds. It's probably much cheaper if it runs in just 1 second with less memory. The second constraint definitely would be the size of the package. So even if you know the process earlier and you were able to train the model, you were able to extract the best model, you have the best hyperparameters, etc., and you have everything in S3, the next problem would be, how do you reduce the total file size to less than 250 MB? And that's the challenge. And when you're using multiple libraries inside AWS Lambda, the challenge there would be, if you add all the packages, all the libraries together, it will definitely exceed 250 MB, especially if you relied on the normal process. Pip install, or just put it inside requirements.txt. You install it, you package your Lambda, and then boom, it's rejected because it exceeded 250 megabytes. So the solution there would be simple. Delete the files. Although it's funny because deleting files may not necessarily get the job done, you have to know that it's as simple as deleting files before you upload it to Lambda. So if you try to search, of course you will be provided with a lot of examples, But getting these things running in production, it will take a lot of practice. And you have to do a lot of trial and error for this to work. So one of the things which usually work would be reducing the binary file size using strip. So if you know about the .so files, if you run strip, usually, majority of the time, it works. You will save a lot of space and file size with that alone. The second part here would be deleting other files. So when I was trying to deploy Facebook Prophet in Lambda, the thing that I did was delete the test folder somewhere. When I deleted the folder, I was able to reduce it by a bit. And then when I stripped the binary size, it was able to further reduce it. And then when it was less than 250 MB, it worked properly. And then what you need to do is basically have a good understanding of the library or framework that you're using. And if it's not going to have errors in your Lambda function, then it's probably going to work. So let's say that I'm not going to use a certain part of this Python framework or library, and I deleted it before I uploaded the Lambda package. It means I did my job well. And then finally, test and deploy your Lambda function. Because if something broke, then you deployed it into production, then you weren't able to get things running. So you have to make sure you test it properly. And every time you try to delete something in your Lambda function, you have to make sure that you try to test it again. So in my example earlier, I'm just going to repeat because this is one of the more important parts. This is a skill that when you use AWS Lambda, you should know how to do this. The constraint would be there's a 250 megabyte limit. The problem would be how do you insert TensorFlow and other libraries that you're going to use inside that Lambda function, which is, when you installed it, I think it's greater than 300 MB. So the solution would be delete files until the total size is less than 250 MB. So those are some examples of which you can delete. And then finally, reduce the binary file size using strip. So if you can write automated scripts and do this before you upload to Lambda and S3, then you can repeat the entire process so that you can try different libraries and frameworks in your project. So what we did in our company is, the easiest way to do this is to use the container provided. And in that container, we just added other things inside that container. So Docker container. And then finally, trying to add those scripts inside that container. So every time we have to build a Lambda function from scratch and insert all those Python scripts and libraries there, it's much easier to just deploy it into production because all the scripts needed to do all of these things are already there. It will save your team time, especially if it's a team that's dealing with more than 5 members. All right, so this is the last part of my talk. So managing machine learning workflows. So when you're dealing with machine learning workflows the serverless way, I'm going to go back to what I mentioned earlier. So earlier, what I said is when you're trying to use serverless functions inside your application, and you're trying to do everything the serverless way, you will always encounter constraints and limitations, which I think is good. It forces people to decouple things. One of the things which serverless architectures and distributed architectures tries to solve would be dealing with a big monolith and trying to scale some parts of your system, which is not usually involving the other parts. So for this one, we're going to use step functions, and I'm going to provide examples and guidelines on how do you deploy these things into production, and how do you make use of infrastructure as code concepts on how you deploy these things. So for the final 2 or 3 slides, you have to take a step back and understand what are you trying to solve here. The reality is that you're not going to be a one-man team. You're going to solve problems. You have to assume that they're not going to work on a single function. They will have to work on different functions. You assign tasks to them, and then they will give back to you the deliverables, and somehow it has to work together. When you have to deal with multiple repositories, when you have to deal with multiple services, things get trickier. So you have to have some way on how to manage your workflows. And if you are part of the management team and you are not allowed to touch any code, let's say that's the constraint, there should be some way to enforce observability of what's happening inside. If I give you instruction, I want this project, I want what's happening inside. I want to know what the state is of that workflow. I want to see something like this. And the machine learning function that you use should probably be there somewhere, and it should only be triggered due to a certain condition. So using step functions, and of course, probably in the future, there will be other alternatives to this one, it will help you manage your workflows. If you try to build your own tool, if you resign, how will the other developers use that tool? It's better to use a tool that a lot of people are using so that documentation is good and the problems of other customers have already been processed when trying to build this. So in my example, I'm going to use step functions and CloudFormation in order to manage my development, staging, and production resources. So the advantage of using CloudFormation, which is basically converting your entire infrastructure as JSON files or YAML files, it allows you to create multiple copies of your architecture and creating that DNA as code in a repository somewhere. So in my example, let's say that you have multiple environments and you didn't use CloudFormation, it's going to be hard to maintain these infrastructure resources because they're way too distributed. Something needs to be done in order to version control these resources. So now that you have CloudFormation in your solution, all you have to do is quote-unquote document your machine learning application inside CloudFormation as strings. Basically, it's a big string structured like a JSON or YAML, and then you deploy it into a development environment, and then you deploy it into a staging environment, and finally deploy it into a production environment. So when you want to do blue-green deployments, all you have to do is version control your CloudFormation templates. So you have a blue template and you have a green template, and when you want to launch your green template, you launch it, and then you test it. If something's broken, roll back the green template and the blue is back. So there. So basically that's trying to combine different tools together and making machine learning applications available in staging and production and making sure that risks are managed well. Because trying to deploy things in production is not as straightforward as it is. Because let's say rollback, you have to roll back immediately. You cannot try to sync things one at a time and trying to do things manually because your customers will experience errors if the rollback process isn't planned well. So that's the last slide. And to summarize, basically what we did today is talk about serverless concepts, machine learning concepts, how do you deploy machine learning models in different ways. So in my examples, I use SageMaker, I use AWS Lambda, and I also use step functions to help us manage our machine learning workflows. So thank you very much and hope you learned something from this talk.